Hi, in exercise FC-1 we will try to find out how the application affects the choice of the frequency converter. So we'll be working with two applications here, a pump and a wind turbine, and the parameters in these two applications, the specifications, are chosen intendedly so that you highly likely will end up with the same electric machine for these two applications. So electric machines will be the same, but the frequency converters must be different, because in a pump application we are working in motoring mode, so the electric machine is working as a motor, while in the wind turbine the same electric machine will be apparently working as a generator. If you are not familiar yet with what 2-quadrant and 4-quadrant drive systems are, what are 2Q and 4Q converters, please read up in the electronic textbook or on internet, because this is important. This is what this exercise is about. So when choosing these two frequency converters, you will have to write down such parameters as size, weight, cost of the frequency converters, as well as their efficiencies and the total harmonic distortion value for each of the cases. So this will help us to have a comparison and draw some conclusions. So let's first work with the pump application. So first we set up all the parameters according to the spec, and we see DriveConstructor have chosen 4 drive system variants for us, 4 system curves here. And if we go down, we see the squirrel cage induction motors, the 4 motors, and if we choose one with 600 RPM synchronous speed, we can then write down the type of this motor for our report. And of course we are interested primarily in frequency converter, so we go down and we check the one which is cheaper. This is wall mounted variant, and then we can go to show report, click on it, and see the overall system parameters like the price or the THD values for the system, overall system, and we can see the electric machine parameters and the frequency converter parameters like synchronous speed, efficiencies at full load and partial loads, so everything we may need. So now let's take a look at the wind turbine application. So here we need a gearbox, and of course the transformer is there because the grid is 6 kV. So we also entered the parameters according to the spec, and we see DriveConstructor have chosen one variant for us. In this case we are now using PM machine. We'll correct it later. So let's first set up the right gearbox, 2 stages with overall gear ratio of 30, 6/5. So the frequency converter should be correct. It should be not 2-quadrant but 4-quadrant, because this is a wind turbine generating application. So let's see, now we have 3 variants to choose from, 3 PM motors, but remember we should have the same electric machine, so it should be squirrel cage induction machine. And we're going to correct this. Go to machines, choose squirrel cage, 3 variants again, not bad. Go down, and we should choose the one with 600 RPM to make the comparison of the frequency converters correct. So let's see, we choose again, select the right frequency converter and go to show report, click on it, and here are the parameters. So you see the THD values are now different because the frequency converter is different from the previous one. And again we see the electric machine, and the power is the same, so it's basically the same electric machine, but the frequency converter is different. Now it is 4Q in the designation, and the price is different, and you can see the efficiency is different as well. So this all you should write down in your report, together with the THD values and all other parameters mentioned before. So what else? We can check also if the filters are correct. So there should be a sinus filter between the frequency converter and the grid, and this obviously makes the price of the frequency converter higher than in the first variant without the filter. Thank you for watching.